Hi again. This is the second in our program on the look at proteins and amino acids. I strongly recommend that you watch the first program because there'll be some terms that are referred to in this program that require that you've seen the first one. Anyway, let's begin with the analysis of how you analyze a protein. The first step is to take our protein and break it apart. What I mean by that is if we consider the following peptide, what we have to do is break that bond that connects each one. You might recall that that's referred to as a peptide bond. To break that peptide bond, we need to introduce water molecules at each of the sites. So in this case, I need to introduce 5 water molecules. I need to carefully choose either an enzyme to make that happen or conduct the experiment in an acidic condition. Once I've done that and broken the peptide bonds, I now have my individual amino acids. I can take those acids now and take them to either one of two tests, chromatography or electrophoresis. Let's begin by taking a look at how chromatography works. Chromatography is based on the movement of an amino acid through either a mobile or a stationary phase. Let's look at that. Many of you might have done experiments earlier in public school where you took colors of ink and had them move through paper. That technique was called paper chromatography. In a similar fashion, I take my amino acid and place it on a strip of paper, or if I want to improve the separation, I use a microscope slide covered with a thin film of either silica or alumina gel. That forms the stationary phase. The mobile phase is my solvent, and that solvent can be a mixture of alcohols, water, ethers, and even acids. I place the paper or the silica gel slide in, and the solvent is then absorbed up through the gel. It is the hope that as that solvent moves through my amino acid mixture, various components will either move with it or stay behind. After several minutes, I remove that slide and I need to spray it with a stain. The amino acids themselves are not visible, so that's why you need to spray them. In this particular case, my mixture broke into 3 components. The component that's highest up had the greatest liking for the solvent. That could be perhaps due to its polarity or size. The one that's lower down had a greater affinity or liking for the stationary phase, the gel or the paper. I now make measurements going from where I started my experiment to where each component moved, as well as how far the solvent moved. From that I calculate something called the retention factor, which is a ratio of the distance that the component moved over the distance that the solvent moved. In this case, for component A, I get a value of about 0.41, and it doesn't have units. I can take that value now and take a look at a reference book of chromatography, making sure that I carefully select the same conditions, meaning I would want to make sure I'm using the same solvent and the same sort of stationary phase, and then I can compare it to that value. And perhaps from that I can then identify what my particular amino acid might be. Now let's look at how the technique of electrophoresis works. I'm going to have a mixture of 3 amino acids, and I've looked up their isoelectric pHs from my IB data booklet. So at a pH of 6, glycine would be isoelectric, meaning it would have a balance of positive and negative charges. Overall, it would not have a charge. Serine, however, if placed in a pH of 6, that pH of 6 is slightly higher than its normal 5.7. That would induce it to form a negatively charged ion. This is why you need to have seen the previous program. Similarly, if I go to histine, which has a pH of 6, that's much lower than its normal pH of 7.6. That will induce it to form a positively charged ion. So in the first step of electrophoresis, I want to operate my experiment at a pH which will allow me to separate my components into positive and negative and even perhaps neutral ions. Let's take a look at the equipment. Electrophoresis consists of a gel, usually made of polyacrylamide, and into that gel I will essentially place my amino acids. They're then immersed in a buffer solution whose pH I've carefully chosen, and in this case pH 6, to allow me to create differently charged ions. At opposite ends of the gel, I connect it up to a battery, a positive and a negative terminal. When I throw the switch, the variously charged ions will move. Glycine won't move in this particular case. Again, as in the previous case, to make these visible, I have to spray them with ninhydrin. The amount that an ion moves depends on its difference in charge from its isoelectric point. So in this case, histine is further from glycine than serine is from glycine. As a result, the histine moved further. So those are two techniques you can use to analyze and separate your amino acids in a mixture and thereby identify the amino acids that are present in your protein. Again, questions are always welcome, and thanks for watching.